All right, it seems like we're live. Hello, everyone. Welcome to another Endress+Hauser webinar. And today's topic is going to be on how we can help you guys achieve your sustainability goals with effective water monitoring. Okay, just before we get started, a quick review on the GoToWebinar interface. I'm pretty sure after 2 years of COVID, most of you are well experienced in how to use any online meeting tool. But if you want a quick reminder, on the right side of your screen, you're going to have a user panel where you can download some additional content that is going to act as a complement material for the presentation today. And we also have a questions area where we can write down any question, comments, or feedbacks that you have. We're expecting the webinar to last around 35 to 40 minutes, so we're going to have some time at the end of the presentation to answer some of your questions. If your question is not answered today, no worries. We're going to come back to you later on via email, so pretty easy. Okay, a quick introduction about myself. My name is Gustavo Queiroz. People usually call me Gus, and I've been working with the company for nearly 13 years, 9 years back in Brazil, and around 3.5 years here in Australia. I've been working, like process instrumentation has been around me throughout my whole career. I started as a service engineer, worked in marketing as a product manager for liquid analysis before moving to Australia and joining the industry management role. Okay, a quick review on the agenda today. Okay, so we're talking about sustainability, which is a really hot topic across different industries, and we're going to talk from a process instrumentation perspective. So we're going to try to answer the question on how what is the role of the process instrumentation in achieving sustainability goals and reducing waste. We're going to talk about data quality. So today, data plays a really important role, especially if we're moving towards data-driven decision making. Okay, so we're going to talk about data quality in the sense of flow measurement. What are the factors that we need to keep in mind to make sure that the data that is actually being supplied to my decision making, let's say, system is actually worth and valuable and reliable. Okay, we're going to have a quickly run through what we call accuracy and visibility trade-off. So there's several types of the technologies available today for flow measurement, and we're going to see exactly where to use each one of them. We're going to quickly go through installation constraints. So if you ever installed a flow meter, you might be aware of what I'm talking about. There are a couple of things that you need to have in mind when, in order to have a reliable measurement. We're going to talk about these constraints and what are the technologies that are now available to help us address these issues. And lastly, we're going to talk about advanced diagnostics and how we can actually use these to leverage our maintenance strategies and reduce our carbon footprint. Okay, so sit back, relax. The presentation is going to be recorded and it's going to be available for you later on. Okay, so let's get started by answering the $1 million question. What is the role of process instrumentation in my sustainability, on your sustainability initiative? And the answer is pretty straightforward. Transparency. Okay, so we have a little bit of a cliche, let's say, quote from Peter Drucker that says that you can't manage what you can't. Sorry, you can't manage what you can't measure, and it actually works pretty well. Just like your personal finance, you need to, if you want to do a proper budgeting, and if you want to reduce how much you're actually spending, the first step that you need to do is actually understand where you're actually spending your money in order to optimize your situation. So when we're talking about transparency, there are three main areas that process instrumentation can actually help us. The first one is what we call consumption baseline, which is basically trying to understand who are your main consumers and trying to have an idea about the dynamics of their process. Okay. The second one is what we call benchmarking. Benchmark is quite interesting because we're actually, if you have the visibility of your consumption, you can have a clear idea and you can start making comparisons of different areas or similar areas or similar processes that are actually producing and having an idea if one area has the potential for optimization compared to another one that's actually doing exactly the same operation. Okay, this is quite interesting, especially when you're talking about sustainability. This is a really good, that's a potential area that doesn't involve a huge disruption of your operation. okay? And the last one is what we call anomalies and pattern detection. A really common, let's say, example in this area is what we call leaks detection. So even though we're moving towards really high automation of operations, we still have some manual intervention, and this is something that can actually open, let's say, some gates for issues and problems later on. So if you have process instrumentation, if you have online measurement, that's something that you can easily identify whether there's any non-conformity and address the issue before it gets into a point where the impact is really high. But more than addressing these three areas, the role of process instrumentation is also to give you high quality data, okay? We're moving towards an area or a period in time where we want to do data-driven decisions rather than rule of thumbs and gut feeling. We are having more and more use of machine learning and artificial intelligence. And if you know what I'm talking about, you know that your model, your decision making is as good as the quality of the data that you're actually using as an input to your models and decision making. So what I want to do right now is really explore how or all the factors that can actually influence the quality of the data related to your flow measurement devices. But before we do that, I want to do a quick poll right now. So a question is going to come up, and I want you guys to answer me. What is the role you see process instrumentation playing in your sustainability initiatives? Okay, so I already mentioned like the three first ones. That's just the one that I just described. But if there's another one that is seen as a potential use for process instrumentation in your sustainability initiatives, please select others and maybe write it down in the chat area, because we can actually share this with the other colleagues as well. I'm going to give you guys 10 more seconds and then we can go ahead. Hopefully everyone can actually see. Okay, so answers are actually coming up. Okay, that's quite interesting. We're going to give you 8 more seconds. 7, 6, 5. Okay, that's quite interesting. That's what we were actually expecting. I think we can close the poll now and share the results. All right, determining water consumption and waste generation baseline. Okay, so this is really the first step, but you can see that it's quite well balanced, the answers in terms of setting benchmarks and identification of anomalies. Excellent, really good. Thank you very much for that. I think we can jump into the factors that affect the data quality of your flow measurement. So there are 4 main areas that we're actually looking at when we're talking about flow measurement in general. Okay, the first one is what we call measuring principle. So there are different technologies available today that can actually be used for flow measurement of water. Okay, you can see here on the chart a little bit of an accuracy, and this actually plays a very interesting role. Very often we can see customers that have, for example, some KPIs to reduce 5-6% of their water consumption in a specific area or machine, but they're very often using thermal flow meters where they have like an accuracy or an uncertainty of 10%. That actually won't work. So you need to keep that in mind when you're selecting a technology, and it has to be aligned with their KPIs in terms of improvement. Okay. Second factor is what we call installation conditions. If you ever installed a flow meter, or if you ever work on an engineering design that actually involve flow measurement, you might know what I'm talking about, but this actually plays a crucial role into the quality of the measurement that you have, and we're going to talk about this in a little bit. Process conditions, when you're talking about water measurements, there aren't many challenges, but there are a few exceptions, and we're going to talk a little bit more about that, especially when we're talking about build-up depending on the application. This is something that can influence negatively on the performance of your flow measurement. And last, the physical integrity of your device. Okay, so you can have a really good measuring principle. It can be properly installed. The flows that are going through the device is really clean. There's nothing for you to worry about. But if there's anything wrong with the device itself, again, it's going to mess up with the reliability of your measurement. So let's start talking about the measuring principle. Okay, so if you are in instrumentation savvy, you might recognize most of these instruments in front of you. If you're not an instrumentation savvy, I'm pleased to introduce you to the different measuring principles that we as a company can supply to you. When we talk about flow measurement, we have two, let's say, main technologies that we often use, which is the electromagnetic flow meter and the ultrasonic flow meter. Each one of them have their specific benefits and advantages and limitations. Okay, the main limitation we have with electromagnetic flow meters is the conductivity of the medium, so it's not suitable for really low conductivity applications or oil-based applications. On the other hand, we have ultrasonic flow meters that work pretty well even in non-conductive media. On the other hand, the accuracy that we have with these devices are not as good as electromagnetic flow meters, but we do have a really interesting advantage here, which is the possibility to install or measure the flow from outside of the pipe. So it's a non-invasive technology. Okay, I want to quickly talk about accuracy and visibility trade-off. So one of the main questions that we have is, hey, which technology do I use in my process? Okay, so ideally what you want to do is you want to increase the visibility of the water consumption, the waste generation on your process site. Okay, usually what we start doing is measuring the inlet and the outlet of the overall production or operation. Okay, and we start increasing the visibility by installing individual flow meters for specific areas. And ideally we will move this up and have the flow measurement for each individual, let's say, part of your operation that is actually consuming water. Depending on the size of your operation, depending on the complexity, moving up and having individual flow meters for each individual application is not feasible. Okay, so what we often recommend is using high performance flow meters, especially for high volumes of water and waste generation. So when you're talking about the inlet and the outlet of your plug, you really want to have something that really has a high accuracy because you're dealing with high volume rates. Okay, and as you're moving down to very niche areas, you can actually afford high, let's say, lower accuracy working principles in order to have the proper visibility of your whole operation. Okay, and how we as a company can help you. We have a really interesting segmentation that covers from really basic operations up to the high performance instrumentation, as you can see here. Okay. Again, this is all this technology that I'm showing here right now is they actually need some kind of like infrastructure for you to send or integrate the measured values and generate store all the information related to monitoring. But if you have, I don't know, maybe specific areas where you don't have any automation infrastructure, we are also able to supply battery powered devices, either with a straight connection into your control system or straight into a cloud solution. If you want to give visibility to different stakeholders, they can actually have the information about the water and waste measurement on your phone or computer. Okay. Moving from the first factor and now talking a little bit more about installation conditions. Okay, I'm going to make another poll right now and maybe ask you a question that I really want to have an idea about your knowledge on instrumentation. Do you know why flow meters require a straight inlet and outlet runs? So for those of you who don't know, straight inlet and straight outlet runs. We have the poll available right now. I want you guys to answer me, why do flow meters require that inlet and outlet run? Let's see how many people get this one right. We're gonna give you guys a couple of seconds. Are the answers coming up? Okay, we have a couple of them, 7% voted. Let's give you guys a couple more seconds. You guys are legends, you guys are pretty good. 17%, 27%. Let's give you guys a couple more seconds. 32, 40%. Okay, once we reach 60%, we can stop. We can close the poll. Wow, really great responses. It seems like you guys are you guys know what you're talking about. So who ensure consistent velocity gradient at the measurement area. Got it right, okay? So the main idea behind the inlet, can you close can you hide the results again, please? Thank you very much. Okay, moving from to the next slide. The main reason why the flow meters actually need the inlet and outlet runs is that because we need let's say a consistent velocity gradient inside the flow meter. Okay, there are a couple, we have an example here. There are a couple of installation factors that can actually cause some disturbances in the flow. Here we have an example of a 90 degrees bend, and in red you can actually see how the velocity distribution actually works. Depending on the measuring principle that you have on your flow meter, you actually need to make sure that this velocity gradient is really stable and uniform while going through the flow meter, okay? So this is something that plays a really important role. Sometimes you get a device that has, for example, 0.5% accuracy, but if you don't respect the inlet and outlet runs, you can forget about the accuracy. This is something that's going to have a really high impact on you. So we need to respect the inlet and outlet runs, but these usually pose a couple of challenges for us. For example, higher engineering costs. So this is something you need to keep in mind while engineering, let's say, the installation point of your flow meter. Maybe you need to make some changes on the design because you need to ensure this specific condition. If you already have a specific area where you need a flow measurement and you don't have enough inlet and outlet run, this is going to increase the installation cost because you're going to need to change the pipe work and maybe try to create this specific inlet and outlet runs. And if you can't ensure this, you're going to have poor accuracy and reliability of your measurement. Okay, so this is a common issue that we have overall when we're talking about flow measurement, or better say we used to have. Okay, because right now technologies for flow measurement have developed a lot in the last 10, 15 years. In the last 2 years, we actually released electromagnetic flow meter that can measure with a zero inlet and outlet requirements. And we have a really good differentiator here. There's no pressure loss. So some suppliers actually supply with a restriction. That's what they usually claim as a zero DN. We can do this with a zero pressure loss. So we have additional electrodes inside the flow meter to actually compensate and understand what is the flow distribution profile. Okay, really interesting. And the good thing about pressure loss, you can actually downsize, for example, pumps, and you can actually save on electricity. So if you want to, if being carbon neutral is something that is part of the sustainability initiatives, this is definitely something that can actually help you, okay? And if you want to know more information, we actually put a case study in the handout section, and I'm going to ask our support team to put a YouTube video on the link, on the chat, where you can actually understand a little bit more on how the technology works. We're trying to give just a quick overview on how the technology works, so we won't go into details. You can check the YouTube video later on, or give us a call. We're more than happy to set up a meeting with you guys and maybe dive down into the details of the technology. Okay, but don't forget to check out the case study there as well. The second technology that we have is also around ultrasonic flow meters. So ultrasonic flow meters, they usually have a really high dependency on flow profile. That's not only ENH, but any ultrasonic flow meter in the market. It's really hard for you to have a really high accuracy measurement unless you have the proper inlet and outlet runs, okay? So we also developed some additional resources for our ultrasonic flow meters, and now we can combine, instead of two sensors, we combine an additional set of sensors, so we can actually measure flow with two sets of sensors, and these allow us to understand and compensate any disturbance that we have in the flow profile. And we can reduce from 15 or 20 times the inlet and outlet runs down to 2 for any of these cases. Again, we have a case in a dam here in New South Wales where the customer would need something around 20 meters of inlet run, and we were able to reduce to something around 2 meters. Maintenance got way easier just by using this kind of technology. Okay, and again, I'm going to ask our production team to add a YouTube video so you can actually have a look and understand a little bit more how this technology actually works and how we're able to measure flow with a really good accuracy with only 2 times the pipe size as an inlet and outlet run. Okay, excellent. Now moving from installation conditions and having a quick overview on the process conditions. When we're talking about water, as I said, in general, we usually don't have big challenges unless you have, let's say, some peculiar cases. I mean, and in a couple of cases, build-up, it can be an issue. So depending on the build-up that you have on your flow meter, this is going to increase the resistance inside the measuring tube, and it will get to a point where you won't be able to measure again. Okay, so we actually have developed a technology that can actually solve this problem. We are able to measure the build-up index inside the electromagnetic flow meters and give you a warning based on the build-up height. So what we often do, what usually happens today is you usually install a flow meter, you let it work, and you only, let's say, do the maintenance once the measurement is gone, once it's actually too late. With this, we can actually understand how much the buildup is actually increasing inside the flow meter, and we can plan the maintenance before you have, let's say, a massive shutdown or really an issue with the measurement of your flow meter. Okay. And last, we're going to talk about physical integrity of your flow meter. Okay, so for those of you who don't know, Endress+Hauser has a concept for advanced diagnostics that we call heartbeat technology, okay, which is actually divided in 3 main areas. The first one is what we call diagnostics, okay, so all the information supplied from the in terms of warnings and messages are actually following number NE 107. So everything, so any message that you have on the instrument display will actually come with the oriented action to actually solve that problem. We have the second pillar of heartbeat technology, which is called verification. So today, the devices are actually able to self-verify and give you a full report about everything that's going on, about the physical conditions of the device. And this is actually going to give you some additional information to be more proactive in terms of maintenance of your device and avoid any kind of, let's say, problem with the measurement and a reactive maintenance. And the last one is what we call heartbeat monitoring. So in addition to the measured variables that you're actually getting from your flow meter, we're actually using all the data that is actually generated for the diagnostics verification to give you interesting key performance indicators. So for example, the device is going to tell you what is the mean time between failures, and you can actually use this kind of information for a more effective maintenance strategy. We often talk about data, but what we need to do, data itself is useless. We need to be able to use that data and turn it into information and turn that information into insights that can actually help improve your operation. Okay, we're going to talk a little bit more about that later on. So talking about verification, what exactly the device is actually checking. So first of all, you have a full verification, not only of the sensor and the electronics and the I/O modules, but we also have, once the device is actually manufactured, we save all the reference parameters in production, and every time you execute a verification of your flow meter, it's actually comparing that the current situation to how it was when it left the factory. So you can have a clear idea if there's any components inside your equipment that is actually drifting or wearing out with time, without a need to take your flow meter out of the process. So this is something that you can run while your process is running. There's no effect on the performance of the device or the availability of your plant. And then you're able to get a really nice report, say, hey, your device is actually working well, there's nothing wrong with it. And quite interesting, this any supplier can come and say, hey, we have self-verification. Our main differentiator is that we have a third party, the TÜV in Germany, that actually attested the methodology that we use to verify our equipment and actually give us a really and it gave us the okay that it's actually a proper verification of your flow meter. Okay. All right, so as I just said, we're often talking about data, but we also need to put that data into context and give it some background to turn that data into information. So the flow meter is actually designed to give you high accuracy data, and we just explored some of the factors that you need to have in mind to make sure that that information is actually reliable for a data-driven decision making. But we also give you the resources to turn all the data into information, for example, as a verification report. So you can have reliable information to support your decision making, and as well using advanced key performance indicators to turn all that information into insights to really optimize your operation and maintenance strategy. Okay, so we move from a reactive operation to a more proactive one, especially with additional key performance indicators, okay, and also process insights such as the build-up monitoring. Okay, all right, I think that's really what I wanted to share with you in terms of flow measurement. I just want to give you a quick overview on a couple of things that we're doing as a company towards sustainability. We can talk about sustainability and how our devices can help you, but we also want to share with you what we've been doing. The first one is there's a company based in Paris called EcoVadis, which is a non-profit company that is actually responsible for evaluating and assessing different companies in terms of sustainability. And we did the survey. They come to visit our manufacturing sites, and they put us in top 1% companies as more sustainable in the market. So we're doing our part in terms of sustainability and contributing to, let's say, to a more sustainable world in the future. And these are some of the projects that we're actually doing in some of our production sites. So we're actually working on solar panels. We actually have some of our colleagues installing some solar panels in our new office here in Sydney. So we take this subject really seriously, and we're also looking to the future and helping our customers achieve their sustainability goals, not only by improving our operation, but by supplying process instrumentation that is actually designed and fit to help you guys with the sustainability goals. Okay, so I think we did it in 27 minutes. That's actually pretty good. I think we have some time for a couple of questions. Let me quickly check here. We have presentation keeps going. Back to just one question. Did everything work well? Yeah, okay. I'm gonna give you guys a couple of minutes. If you guys have any questions, please just put them in the chat, and then we can have a little bit of a discussion, okay? Let's give a couple of minutes. No questions so far. No, let's give it 2 more minutes, 1 more minute. Well, if you don't have any questions now, that's all right. I think we can wrap up and finish the webinar now. But if you have any questions that didn't come up right now, I'm pretty sure they're going to come up later on. Feel free to send us an email, and we're more than happy to have a chat with you. So thank you, everyone, and I'll see you in the next webinar.